Okay, welcome to Nested Loops. We're doing chapter 19 of Design Patterns Explained, second edition. And I'll turn it over to Andrew.
All right. I'm here in Stanford. I will present my screen. 1 second. Sure. So here's the template pattern. Okay. So overview. For this chapter, we're going to go back to the e-commerce case study. We'll talk about the template method pattern by adding requirements to the case study. We'll talk about the intent of the template method, their key features, how it's used to reduce redundancy, and some of his experiences using template method. So more requirements. In this application, they'll start using Oracle and SQL Server databases. His idea is that you can write a query somehow to an object, and whether the object uses SQL Server or Oracle will be determined or will be handled by the template method. So, for example, he knows that he has to have a connect command, and that it has to send to the database. The select command, just your typical select query, and then return the data set. So that's the flow of what he wants to use the template method with. So the template method is a pattern intended to help us generalize common processes at an abstract level from a set of different procedures. They are different methods, but they share the same conceptual process. The template method pattern is about controlling a sequence common to different processes. So applying the template method to the international e-commerce site. So here's the UML diagram that we're going to look at. So we have a do query that's public, and then we have some methods that will get replaced by the different types of database. So instead of just having a format connect, yeah, I'm not sure about the UML syntax for the hashes.
That's just showing that that is.
I know the plus is public.
I think minus is private. You have to go ahead. I'll look it up while you talk.
Okay.
Protected. Hash is protected.
Protected. Okay. Thank you.
Plus is public. Minus is private. Hash is protected.
Thank you. Oh, so explaining the UML diagram. So we'll break it down into the three methods: do query, format connect, and format select. The do query is implemented as follows. Although the abstract class knows this format needs to take place, it doesn't know how to do it. My goodness, there's a lot here. These are all three different methods, right? A public, a protected.
Mm-hmm.
So I'm trying to make sense. This starts executing until the format connect method. Because the Oracle Qt object was requested to perform do query, the Oracle Qt format connect method is called.
Yeah.
So each of these are
So if you
inherited.
were to highlight in the little UML comment to the right, go back to your diagram there.
Mhm.
So the template method itself is doQuery. So this is when we say the template method, doQuery is the template method, but you see right where your cursor is there, it calls format connect, and the next line it calls format select.
I see.
So the template is we always connect, we always select, and then we return the data set. And so Oracle and SQL Server, they both have unique connect and format select methods. So they don't redefine doQuery. doQuery is the universal template.
Mm-hmm.
And if we add a MySQL, it would be a MySQL Qt. But MySQL's format connect and format select may be different.
Right.
And so each one of those overrides those two methods. So the template is the doQuery method. That's the thing that everyone follows in this order.
Yes.
But for my specific database, I'm formatting the connect and the select perhaps differently. So each one of these will override that. Potentially, if there's something that's universal, you could define it at the query template level. And then it's only overridden by things here. In this case, I think it's not done that way. And yeah, so the other page is basically explaining that, look, the template is doQuery, and for Oracle, format connect is something, and then for SQL Server, it's something else.
So is Oracle Qt inheriting query template?
Yes, so that's what that little open arrow is.
Mm-hmm.
We inherit from there, and it overrides those methods.
Okay. Query control is just something above?
It's something that uses a query template. So
okay.
There's a control. There's somebody, that's the using program. The using program gets a query template, and it doesn't care what kind it gets, just that you can turn around and go do query on it.
Okay. Okay. All right. Well, I guess that explains the UML diagram. Thank you, Forrest.
Sure.
Using template method to reduce redundancy, should be redundancy. So he goes here to explain on how he uses the template method. On one occasion, I was asking the team lead to describe a typical problem they had. He related to me how they had 2 support systems for different partner companies. The rules were pretty much the same, but they always had subtle differences, and it just became filled with if-then-else statements throughout the code. So it's just showing how the code gets bigger and bigger by just adding if-then-else statements, as well as copy and pasting the code for each. So this is the copy-paste method.
I gotta say, that's really bad pseudocode.
Yeah. So that's one method. It goes on using copy and paste to create new code. Creates redundancies. Yes. Highlighting the differences between the two. I guess he's actually showing what's the same between the two.
Yeah, he's trying to show you their stuff is the same, stuff is not the same. And I guess capital D is a variant of D, whereas in some cases, like the step 1, you have A, but then you have X, which is different, and B than step 2. So yeah, basically,
that's hard.
It's an interesting way of, I probably would have made more pseudocode that weren't just letters, but words that were like similar. Like, I guess you're trying to show some is the same and some is different. Yeah. So I guess that's an okay way. And I'm guessing the capitalization is similar.
Mm-hmm. I was reading the Gang of Four book on template method, and they had a pretty nice example on, you have a barista and she has to prepare coffee, or she has to prepare tea, and they broke it down into pseudocode of, like, you have to boil it, you have to brew it, you have to pour it into a cup, and then you have to add the condiments. And that was the template method, and it showed that, you know, for coffee, you have to put it like in a percolator to brew it. And then the condiments that you add are milk and sugar, while in tea, it was like you have to steep the tea for the preparation portion. And then to add the condiments, they had lemon. So it was kind of nice to see that they were inheriting from an abstract class called caffeinated beverages. And that was kind of clear to see, like, okay, caffeinated beverages both have boil the water and pour into a cup methods, but then they had abstract methods for, you know, prepared or brew the solution and then add the condiments, which would then get replaced by whatever it's inheriting. Like, so the children classes would just modify that, or else I guess in Java, if you try to call an abstract method, it won't work. So I think that was a little bit clearer than this one, but I still wanted to try this. I just didn't give it a chance to read it over again.
Yeah.
So here's eliminating the redundancies. We were able to see the things that were changing and the things that stay the same. We were able to see the C, the F, and the I's were both common in both of them, whereas there were different methods for step 1, 3, and 5, and each class just defines those methods.
Yeah.
So an approach to avoid duplication in the first place, first refactor the first solution to pull out the code that will change. Second, create a base class that contains the methods that don't change. And third, write new second class, which would then create those methods that, you know, are varying between different objects that inherit from that base class. Steps for refactoring. Refactor your code without adding any function, so the new function can go in following the open-close principle. Add your new code, touching only the factory and the new code. Again, so the factory would be the base class.
The factory would produce the class that you choose, not the base class.
Oh.
In general, when you get an object that you don't care what the subclass is, you use a factory so that you don't need to know what type it is. It's level of indirection. Yeah. Right, that thing, the query control, it gets an object of type query template, right? And so typically, especially in Java, you have a like query template factory, which gives you this object back. That allows query control not to be dependent on Oracle or SQL or MySQL or Qts. Right? I just simply, you pass it a factory, the factory gives you back a subclass of query template, and you just use it without knowing what it is.
Yeah. Gotcha. Using the template method. The story I just related is an example of how knowing patterns can help one follow the practices of extreme programming. A skilled XP designer would know to consider something like the template method pattern in the case described. If this were the best way to handle avoiding redundancy, the pattern would be implemented. The XP designer may not think of himself as following the pattern, but knowledge of the pattern gives one an option he might not think of otherwise. Unfortunately, a designer not yet experienced in XP may just never recognize that such a solution is available. He might not even recognize that by copy and pasting, he is creating a redundant procedure, even if he changes all of the code. This again confirms my point that patterns are guides. They can be used as effectively in an XP-style coding project as they can in an upfront design one. So summary. The key features, the intent. Define the skeleton of an algorithm in an operation, deferring some steps to subclasses. Redefine the steps in an algorithm without changing the algorithm structure. Problem. There is a procedure or set of steps to follow that is consistent at one level of detail, but the individual steps may have different implementations at a lower level of detail. Solution. Allows for definition of sub-steps that vary while maintaining a consistent basic process. Participants and collaborators. The template method consists of an abstract class that defines the basic template method. classes that need to be overridden. Each concrete class derived from the abstract class implements a new method for the template. Consequences. Templates provide a good platform for code reuse. They are also helpful in ensuring the required steps are implemented. They bind the overridden steps together for each concrete class, and so should only be used when these variations always and only occur together. So here's the figure I was talking about. Create implementation. Create an abstract class that implements a procedure that using abstract methods. These abstract methods must be implemented in subclasses to perform each step of the procedure. If the steps vary independently, each step may be implemented with a strategy pattern. So here's the concrete class inheriting the abstract class and defining the primitive operations, as well as the template method. And then this, I guess whatever's calling it, knows to call the primitive operations, I think.
No. Whatever calls this class calls the template method.
Oh, okay.
Which uses the primitive operations.
Gotcha.
And each subclass will override primitive operations as appropriate.
Okay. Gotcha. Review questions. The template method pattern makes the method call in a special way. What is that?
I don't even understand the question.
Template method makes the method call. Did I write that right?
Did he? No, you wrote it. That's
Yeah.
what the question says. I might have missed where he said this is the special way. I mean, I know how the pattern works. I just don't understand the question. Makes the method is a special way. What are you talking about?
I don't know. What did I write? I don't know if that's the right answer.
Method in the parent class. Okay. Without knowing what the question means, I don't know.
Well, we can skip it.
Yeah, we can. I'm just going, I don't know.
According to the Gang of Four, the intent of the template method pattern is to define the skeleton of an algorithm in operation, deferring some steps to subclasses. Redefine the steps in an algorithm without changing the algorithm's structure. What does this mean?
Yeah. So here's the interesting thing. I read this and this makes 100% sense to me without having to redefine it. So I would throw it in the path of someone who this question is less clear. And then if we can elucidate what it is that's not clear, then hopefully we have something of value for people that are less familiar with the pattern.
Yeah, I feel like what he's saying, or like what the purpose of this is that you have a common entry point to the algorithm. That's the method that's shared between all the classes. And so the methods that are implemented in the concrete classes, the way that they're called doesn't change because they're called as part of the bigger algorithm, like the that's created in the abstract class. So when you redefine the steps, you don't change the algorithm structure because those methods that you're defining in the concrete classes are still going to be called the same way that they're called in the methods of the abstract class.
Mm-hmm.
If that makes sense, if I'm explaining that.
Yeah, I mean, it's real. The sentence is real clear to me. So, Andrew, was the sentence clear to you?
Don's explanation was clear. Where I get caught up is redefine the steps in an algorithm without changing the algorithm structure.
Okay, so that's good. Which part do you understand in that sentence? Which part do you not understand?
I understand define the skeleton of an algorithm in an operation,
Yeah.
and deferring some steps to subclasses. Like if it was just that, then I can say, oh yeah, I can see, the second step now defers to this other step, or this other subclass.
Yeah, and I think the idea is that the template method doesn't change.
Yes.
So you only change, like let's say the template method was to call steps 1 through 3 and wait like 5 seconds in between each one. You would not change that template method. You would just define the steps in the subclasses.
Right.
And what the steps are. So you don't change the algorithm.
Mm-hmm.
You just redefine the steps.
Yeah.
Yeah, I think you're right. If I just think of it as there has to be a template method that goes through and does the same set of steps, that I won't switch the order of the steps somehow.
Right. That's the fun. The template method is the algorithm, i.e., these are the steps that you do in this order.
Mm-hmm.
And that never changes, but the implementation of the steps can change. And it goes back to your barista thing. Add condiments. Well, for black coffee, it's nothing.
Right.
For a frappuccino, it's whipped cream and sugar and caramel, whatever. Right? But it's always, we always add that after we've brewed.
Yes. Yes,
Right?
that makes so much sense.
So the algorithm is set. It
Mm-hmm.
never changes, but the steps change. And for some of them, some of the steps are the same. Like a whole bunch of coffees, the brewing is the same, but the condiment's different. And then maybe for some other expensive coffee, you can't just brew it the normal way or whatever. You have to do it some other way. So that one changes. But for a lot of them, it's the same.
Right. So same with the database query one that they had, where it's like, oh, you want to connect to a database first before performing the format select.
Yes, you can't possibly query it before you've connected.
Yeah.
Yeah.
The Ganga 4 calls this a template method. Why do they do this? I have a better understanding of that now.
Yeah. It's a decent description of what it is. It's a method that's a template.
Doesn't change.
I think this is probably one of the most common patterns that I've used without really knowing that it was a pattern.
Yeah.
Because it just makes sense as a way to implement things that are where you have some sort of common overall behavior, but you don't like you're going to change the tiny details in the subclasses. This just kind of naturally happens.
This is if you refactor away your duplication, this naturally happens, or it can naturally happen if you have the right outlook and habits. So where you start getting, oh, you got this, then you have that. Sometimes it's because you add something that's basically the same as something exists. Sometimes you have two things that you implement, you look at them and go, oh, these do almost the same thing. So if we get around to doing refactoring, any of the refactoring books to study, one of the typical methods for refactoring is when you have two things that are similar, is you either make one look like the other, or possibly you move them both to a common thing. But it's usually easier, and that's the beauty of refactoring, is they give you steps to do what they call safe code changes. If you follow the steps in this order, your changes are safe. So let's say we had two things, and after we look at, oh, these are really similar. You'd look at one of the two and you say, oh, this is the better order, and you make the second one look like the first one. And when the second one looks like the first one and it works, which ideally passes all the tests, but if you don't have tests or TDD, you might not have them. Once it works, then now that the two things are the same, you could extract out the abstract class, which has the part that is the same, and then the subclasses will keep the part that is different. And yeah, that's a good. I want to say in I forget, it's the Green XP book of the XP series, where they have a whole bunch of exercises, and I think, oh yes, it's the one that test in the web developer thing about removing duplication. They did that example in Java, and they do the refactoring where they make two things look the same, and then they do away with the duplication. So it's not template method, but it's the same kind of generic refactoring technique where you make two things that are similar look the same, and then you can get rid of the thing that's the same. In the case of template method, you abstract it up into an abstract parent class. In that example, the code example, it became a method that you just use in both places, and you just basically remove the other one. But it's the same mechanic of just safely refactoring away duplication. So once, and I hope what I'm saying is not all mumbo jumbo to you. When you've done this for a while, or you're used to it, you go, oh yeah, it's just this. The template method, like Don was saying, oh, it just sort of happens. If you are good about looking at what's the same and refactoring away duplication, it just kind of happens. But if you're not in that habit, then it's nice to see a method and go, oh, this is what I should do to get rid of duplication.
With refactoring, I always do where I find something that's pretty similar, and I just make a new method out of it, but I don't abstract up to create a parent class to then inherit. So I feel like that's probably where I should go next, maybe, depending on the...
It's where it's appropriate. In this case, because there is that skeleton algorithm that doesn't change, it gets moved up. It's a lot about doing away with eliminating duplication is where do you put it. In some cases, you make a new method and then everyone uses the new method, and that's appropriate. In this case, where there's a template method where the subclasses have separate substeps, it makes sense to push it up. Sometimes it makes sense to pull things down, which isn't so much. It's not so much. Not exactly remove duplication, but if we look at like the refactoring term, there's pull up method, which means move it to a higher level class. There's also push down. So sometimes where you move things makes sense up or down, or sometimes sideways. Right? But in the case of template method, because I have two things with commonality, so then I move that commonality up to here so they can inherit down. Sometimes you have peers, oh, these are similar, well, I'll make them the same and then just use one. And I don't know if anyone was looking at my video camera, but I was using my hands to try to jazz hands, sort of that. If that makes sense. All right. Is that all clear?
Nope. What is the difference between the strategy pattern and the template method pattern?
Kind of sort of addressed that with my jazz hands. So, anyone want to take a shot?
I felt like I did the strategy pattern.
With your question, actually.
What's that?
Your question kind of addressed that. Really
so I guess that is the difference between the two. That one, it's like kind of where you push the refactoring.
Yeah. Template, they're often used together, and he made a mention of that above, where the steps themselves could be strategy. But strategy is basically replacing, I want to say, replacing the algorithm implementation where they're one of the things in OO that is not initially intuitive is everyone doesn't have a problem of replacing objects with other objects, but I want to say it's still kind of basic OO, but it's not. People that are not read up on OO, it's not basic to them, but people who are, it is. Where in the case of strategy, I am making an object an algorithm. I'm making something that does something instead of is. I've made verbs into an object. So in the strategy pattern, I can flip strategies and something that didn't really explain this job, but something in my other job, we would have these image processing algorithms. And we could have different things that say did compression, but different kinds of compression. So we were able to strategy change out what kind of compression. Maybe this one is optimized for speed. Maybe this is optimized for size. They're all called the same way. And we just kind of interchange them. So in the strategy, we've objectified a verb, we've taken that strategy and we've made an object. And once we've made that verb into an object, now we can change them out. The command pattern also takes an action and makes it into an object, which in functional language is less of a deal, but in non-functional languages. So in the strategy, you don't pull up the comment algorithm. You could, but then that makes a template pattern. So template method is I've got some stuff similar. I'm gonna go in to those watching online switch. So in template method, I have two things that end up having the same. So I pull up the commonality here, and these guys implement. Strategy is like, I got this, or I got this. And strategy allows me to put different ones in place. So you can see they're related. We're still pulling away the, in the strategy case, what's common is the interface and possibly the results. The results might be the same with a different method or something like that, where template takes the commonality and pulls it up into the template method that the set guys have below. All right.
And that's it. No more questions.
So I'm trying to think if I use this pattern all the time, but I'm hard pressed to give you an example at the moment.
I can see myself using this pattern. I just haven't thought about pushing or pulling up these refactorings.
Without revealing what your day-to-day work is, your day-to-day work could clearly benefit from a template method approach.
Yeah. Now, would it be smart to try to implement it throughout all of the objects?
My thought is there's not a single template, but probably like 2 or 3 templates.
Right.
Which you could still do it, because if you look at the template method in question, you have the same 5 or 6 components.
Yes.
Not all of them use the same 5, or some do it different, or some skip some.
Yeah.
But I'd be willing to bet like there's probably only 2 or 3 templates.
Yeah. No, it depends on their use case. But I was going to ask, since we use Ruby, would we in the template how do I say this? In the abstract class, we don't really have abstract class, but in the parent class, would we define methods and then, raise an error if it's not replaced by the child class?
That is a way of making Ruby act like the root programming language that have that, because that's kind of what happens. If I do that in Java, if I make and I forget the term, virtual class, whatever the one that's pure virtual,
I guess it's called a virtual.
Compiler actually won't let you subclass the pure thing if you don't override the virtual methods. You could do that at runtime. The question is, it's more of a safety measure. Do you have to do that? You don't have to do that. If you have either good testing, which the drawback, and people will say the drawback with dynamic languages, you don't have that kind of compile time testing, so you need more testing, and I would argue that you should probably test anyways, whether or not that's built in for you. But yeah, you could do it that way. Make sure the only problem with that error throwing is you find out at runtime. It's a bad time to discover in production your code's not working.
Yeah, that's true. Oh, and how different is the template method pattern would say something like how we use modules in Ruby, where we'd say, oh, we have this, we can say we have this caffeinated beverage module. And then that kind of sounds, I feel like I might be confusing the two, where we're like extending certain objects with the module compared with,
All right. Well, if we look at this way, it is really the mechanics. The mechanic is you move something up.
Yes.
Right? Now, it so happens in Ruby, you could do that a number of different ways. One is you could inherit, you could put that method in a module and then inherit from that and then override the method you need. I don't know that I would do it that way. You could certainly do it that way. I just think it's harder to detect in reading the code. Let me think about that. So if I inherited from a parent class, if I have like, you know, new guy inherits from this parent class, and then I define the two methods, I suppose you could, and if you named it, the thing about like naming things after the pattern is a lot of times you reveal the structure. There's mixed opinions on this, because if you change the pattern, you have to change the name. But a lot of times, well, for example, active record base, we name the pattern, so you know what it is. But if we decided to change that for, I forget what the other one is, data record, then we'd have to change the names there. But if I had so-and-so class inherits from blah blah template, I kind of know that I'm doing a template and the methods are overhearing. If I include the thing, I guess with the right naming, you could make it as obvious, you know, class so-and-so include blah blah template. So if you name it right, I guess it's about as clear. The beauty in Ruby is you don't need to inherit, because you can just monkey patch. In their case, you can include the module and just why not monkey patch? I'm sorry, duck typing. In Ruby, a lot of structures that require inheritance and not languages, you don't have to do if you just happen to match the signature. That being said, following the pattern the other guys use is often easier for people to understand what's going on, if nothing else, because they read it in the book that way. I think there's a value to that. If you do it the way in the book, even though that's not the way you have to do it, it's in theory easier for people to understand or grok or modify, because they can go back and look at the book and it matches the book. You have to do it that way. In Java, C++, C#, you do. You don't have to do it that way in Ruby, but it never hurts to look like the other one.
I feel like using a template method possibly makes writing tests easier. You might have like a template method and you write a test to say, hey, do all these methods, do they always come out with the same, like if I do a parse method, do I always get like a hash coming out at the end or something? I don't know. That's one thought. It's just maybe if I use template methods more, I'll just have like, I hate to say it, like base classes for tests that then I can just build off of.
Maybe. I mean, you can use template method in your tests. You could. I thought that Al had an example of something like that in one of the chapters we recently did, where he said blah blah makes it easier to test, or something like that. Was it facade? In my mind, it felt like template method. I think that the real key is template method. Just once you've discovered there is a template method, i.e. an algorithm that doesn't change for the variant cases, then that's a good shape for that kind of thing. If you want to reduce the duplication and generally make it easier to maintain, that's a good result. Yeah. I always feel like I'm rehashing the definition. It's one of those things. When you understand it, the definition is very straight to the point. And if you don't, then you need a bunch of words to realize, oh, it's just that one sentence. One sentence you have. Skeleton of an algorithm and then deferring steps to subclasses. Yeah, makes a lot of sense. Once you've done a bunch, it'll make a lot more sense. If you come and revisit this in a year or two, you'll probably come going, God, I really get this now. I barely got it at the time. It's another thing, if you came up with it on your own, you understand the pattern really well. All right, anything else?
That's it. That's it for me.
I'm going to look forward and see what the next one is. Factories. Okay, 1, 7, 2. Ooh, that's super short. The factories is like 5 pages. And then singleton pattern and double check locking 1. That's short too. So I would say one person could do at least 2. An object pool 1, 2. Ooh, these all 3 of the next ones are super short. Factory method. Oh, factory mode. Oh, wow. I would say in theory, one person could do up to chapter 23. These are literally small pages. I don't know if anyone have interest in these patterns. They're all super easy. So when I look at the titles, they're actually all super easy.
I'll take 2 of them. I'm really slow with this stuff, but I'll take 2 of them.
Okay, so then that would be
right. Is that get us up to 22?
Yeah, factories and we'll just go with that. Factories and singleton.
All right.
All right, that'll be awesome. I look forward to your presentation. Well, thank you for listening to Nested Loops. I hope you learned something. Have a good day.
Cool. Thank you.
All right, thank you.
Yeah. All right.